We're going to be using half-angle formulas to figure out trig ratios at certain degrees or radians. So for example, what if we wanted to know sine of 15 degrees? This isn't really on the standard unit circle, but we can actually use half-angles or half-angle formulas to figure that out. Same for cosine of, say, 11 pi over 12. Anything over 12, you can use a half-angle since you know over 6 to figure out a trig ratio. What about cosine of 165 degrees? Yes, we can figure that out. We can use half angle. 165, for example, is half of 330 degrees, and therefore we could use a half angle. Finally, tangent of pi over 12. Again, we could use half angle formula because pi over 12 is half of pi over 6, and we already know that on the unit circle. Here is a review of the half angle formulas. First, we have sine of theta over 2, cosine of theta over 2. I'm not going to dive into these because we've already spent a lot of time in previous videos on half-angle formulas. In this lesson, you are not solving for theta. You are actually using a familiar angle, theta, to solve for a trig ratio of theta over 2. So for example, since we know every trig ratio at 30 degrees because it's on the unit circle, we can easily figure out 15 degrees because that's just half of 30. And that's exactly what we're going to do. So for example, we might figure out what is sine of 15 degrees. We can use a half angle since that's half of a familiar angle of 30. We might want to figure out cosine of 11 pi over 12. That's going to be half of 11 pi over 6, right? And therefore we can figure it out. Next we have cosine of 165, which is half of 330. We already know 330 on the unit circle, so we could half that to figure out cosine of 165. And finally, tangent of pi over 12. Pi over 12 is half of pi over 6. So without further ado, our first example is, what is sine of 15 degrees? So how do we know when to use a half angle? Well, let me go ahead and draw us a little arrow here. 15 degrees is, let's use a different color here, half of what angle? Does anybody know? Okay, so 15 is half of 30, right? And since 30 is already on the unit circle, we can cut that in half to easily figure out 15. So again, we're using a familiar angle on the unit circle to figure out an unfamiliar angle, 15. This will work for any multiple of 15. 15, 75, 105, any of those angles will work. Heck, it would even actually work for angles we already know. So again, here is the review of the half angles. Since we're talking about sine, we're going to be using this top formula, plus or minus square root of 1 minus cosine theta over 2. Step 1, find theta. We know that we will be using the half angle, so therefore if theta over 2 equals 15, what's twice that? Twice that would be 30 degrees. And 30 degrees is a familiar angle we can use to find 15 degrees. Step 2 is going to be to write out the formula. Let's use some different colors here. I like to do that, so let's do yellow and pink. Here's our formula. Sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2. This plus or minus does matter, so I want to ask you, what quadrant is 15 degrees in? Okay, and I will use some more pink. And we know that 15 is going to be in the first quadrant, right? And so we know that sine is going to be positive. And therefore, in our formula for plus or minus, we will be using plus square root since sine is positive in the first quadrant. So next we're going to be plugging in theta. Now notice what theta is. Theta is 30. Theta is, whenever you're plugging in theta, again I'm going to use, be very clear about this. Whenever you're plugging in theta, that angle you're plugging in should be the familiar angle, the angle that you already know, 30. You're plugging in 30 to figure out 15 because notice right here 30 over 2 is equal to 15. So you're never plugging in the multiple of 15 in for theta. It's always the 30 or the 150 or whatever the familiar angle is on the unit circle. Okay, step 4 is to solve. The answer will be positive since 15 degrees is in the first quadrant, so we will use that positive next to the square root. So sine of 15 is going to be equal to plus the square root of 1 minus square root of 3 over 2, all divided by 2. In order to combine the top, I need common denominators, so I'm going to write 1 as 2 over 2. So I now have 2 minus the square root of 3 over 2, all divided by 2, inside of the positive square root. So finally, since I'm dividing by 2 twice, that's dividing by 4, so I have that right there. Then finally I can distribute the square root to the top and bottom. I know the square root of 4 is 2. The last thing I'm going to do is basically just write that 2 as 1/2 times whatever the square root is. So the final answer is that sine of 15 degrees is equal to 1/2 of 2 minus the square root of 3. So there's a bit of a problem with this answer, not a huge problem, but we have a square root inside of a square root. Now this is 100% accurate, and this will give us the trig ratio of sine of 15 degrees, meaning the opposite side of whatever that triangle is divided by the hypotenuse. I will show you right now. Since I'm talking about it, it's better to see a visual. So let's say this is a 15-degree triangle, right? If I figure out the opposite side and I divide by the hypotenuse, I will get that ratio back, okay? I'm going to get, basically, I'll just rewrite it as a ratio since that's what it is. I'm going to get square root of 2 minus the square root of 3 all over 2. Now, there is another way to solve for sine of 15. It's basically sum and difference formulas for trig functions. And when we go to fill in the unit circle with multiples of 15 and 75, we will use that formula because it actually comes out a little bit cleaner than this. In other words, you're not going to have a square root inside of a square root. But for now, we're going to use half angles because that's what we know so far. So final answer, sine of 15 degrees is equal to 1/2 times the square root of 2 minus the square root of 3. That's it for this particular example. If you have any other questions about it, let me know.